Hello and welcome to this new eCHO episode today. This is episode 124. And today we're going to have a special episode talking about something that was mentioned last week with Nico. He had a guest, Joseph Ligier, who created a Terraform provider to manage Cilium installation, as well as cluster mesh. And well, he talked a bit about it last week, but there's so much to say on the subject that we thought it would be good to actually spend and now we're actually looking into this provider and seeing what can be done with it. So I'm happy to welcome for the second time in 2 weeks, Joseph Ligier. Hi, Joseph.
Hello.
How are you doing?
I'm fine, and you?
Good, good. So you introduced yourself with Nico last week, but maybe some people were not here. So
Yes.
can you introduce yourself again?
I work for Accenture. I'm a specialist in Terraform, AWS, and Kubernetes, of course, and maybe Cilium. I don't know if Raphaël think.
Oh, that definitely counts. I think you've done more labs than the majority of people.
Yes, but
so, really, you've done a lot of Cilium.
To do lab, is it exactly for an expert on Cilium? I'm not sure.
I don't know. All right, so this is actually the US slot today. So I hope we will be welcoming people. If you're coming around, leave a comment to say hi, and we're gonna get started. So let's start by looking at some examples, right? Last week you showed a bit how to install Cilium using the Terraform provider. What I suggest is we can have a look at this. I'm going to start. Oh, you can present this already. So let's see. Do you have something to present already? Yep. So yes, can you show maybe the code for the installation using Terraform?
Yes.
Or do you want to?
Sorry, what do you want?
So the code to install Terraform like from last week, and then we switch to cluster mesh maybe later. I can pull in the example as well if you want. That's good as well.
Okay. Is about cluster mesh or Cilium?
Well, let's just do Cilium just to have an idea already, and then we'll add cluster mesh.
Okay. So I clone the repo. Yes. You can see the providers, Kind and Cilium providers.
Yes. So we're seeing here, for people that may not be familiar with Terraform. So Terraform is a tool that allows to do configuration management. It is idempotent, which means that you can apply several times and it will manage the state of the resources. And so here you're configuring Terraform with two providers, right? There is a Kind provider, which is, I'm guessing, a standard provider that you use to install Kind, so a local Kubernetes cluster. And then you had, can you show the code again, please, that you had just before?
Yes, sorry.
No problem. So there's a Kind provider that's configured, and there's a Cilium provider, which is the one that you wrote, right? And then the Cilium provider here is configured to use the configuration that was generated when the Kind cluster was installed, right? So we have someone that joined. Hello, Andrew.
Hello.
Andrew is happy to be participating in the Terraform presentation today. This is cool. We hope this will be fun. So then the main code. Yes. So what is this doing? We have a Kind cluster resource. This is provided by the Kind provider with a name for the cluster, a configuration for the cluster. So this will configure a Kind cluster on your machine. And then there is a Cilium resource which will install Cilium. with specific configuration, right? So this is what you showed last week, right?
Yes. So
yeah, I think we can. This was like really to see what you did last week, and then maybe we can switch to the cluster mesh approach. Maybe I think I have cloned it here. Let me see. I will present on my screen and we'll clone it here. If you're okay with this. All right. So there, I'll share my screen. This here. There you go. And the example for cluster mesh, you have a repository, right, that is available on GitHub. So I'm going to clone this repository. And have a look at this here. So it should be pretty similar to what you've just showed us, right? There is versions.tf. So in Terraform, usually versions.tf is where you put the requirements, the version of Terraform that is required, plus the requirements for the providers. And right now, because I've just cloned, the providers are actually not installed on my machine, so they will have to be downloaded. So we're using, again, the kind provider, the Cilium provider. You said you released a new version today, right?
Yes. It's
Does that mean I need to upgrade this? Do I need to update this field here?
This means it's tilde and plus 0.1. It means it's superior to 0.1. And
okay, so this is fine. There's no specific requirements, nothing I need specifically. Okay, and we're requiring Terraform 1.3. Actually, just for fun, I'm going to use OpenTofu instead. Also because it's a CNCF product, right? So since I'm a CNCF ambassador, I need to talk about CNCF products. But I'm more used to Terraform, so I think it'll be the first time I use OpenTofu, actually. So exciting time. And then here, this is the configuration. And what do we have? Two Cilium providers here, actually. I see there's a kind provider and there's provider Cilium, but twice. Why is that? Or three times, actually.
Yes, there is the first provider is mesh 1, means it's the first cluster mesh. The second it's for mesh 2 is the second cluster mesh, and global it's for join between the context between the mesh 1 and the mesh 2 to
so what we're going to
yes.
Okay, so what we're going to do here is we're actually going to create two clusters, right? Two kind clusters, one that will be called mesh 1 and the other mesh 2. And then we're going to install Cilium on each of them using the Cilium provider, right? And then we'll mesh both of them. And so we need three instances of the provider, one that specifically manages each of the clusters. So that's two already. And the last one, which is global, so that it can join the two clusters. That's correct, right?
Yes.
Okay. So this is the equivalent pretty much to when we use Cilium, Cilium cluster mesh enable will be the equivalent to actually installing cluster mesh on each of the cluster, and then Cilium cluster mesh connect to join the clusters together, right? Using the Cilium CLI.
Yes. In fact, Terraform Cilium provider used a library of Cilium CLI.
That's great. That's what I wanted to dive into maybe a little bit before we show how this works. Diving in a bit into the Go code. I like to dive into the Go code and look at the provider. So what do we have here? We have the main.go in the provider. So Terraform providers are written in Go. They're executables that are installed and that Terraform can execute to provide functionalities. And so here, what do we have? This is like the standard framework for Terraform providers.
Yes.
And we have this. This is itself, right? This is the repository itself. And here we're instantiating the provider and serving the provider.new, right?
The code, I don't.
Yes.
The main code is in a Cilium
yes.
directory.
Yes. So in the Cilium directory, we have the provider.go.
Yes.
And that's the main provider code. And this main provider code actually will link to different part of the Terraform framework to create providers, to create data sources, create the provider itself, create the provider schema. So that's the parameters for provider, right? To configure provider. Resources and types that we might use. And here you're essentially creating a provider.
And
configuration,
context,
the
config path.
So context will be the Kubernetes context, right? To manage the cluster.
Mm-hmm.
Oh, that's the config path. So what is the context then? Oh, context of config file. Okay. So config path is the path to the Kubernetes configuration. And context is which context to use inside the kubeconfig file. Okay,
exactly. Exactly. If there is a lot, some context, you can find in which context you install Cilium.
Okay, and then namespace is which namespace we want to use to install Cilium. Okay, yes. This is great. And then we have the configuration for the provider. The configuration for the provider checks the namespace. By default, it's kubesystem. And then it can use the kubeconfig environment variable for the config path, or the config path from the parameter. So it also honors the kubeconfig variable. That's good to know. And then it creates a Kubernetes client. Okay, that's good. That will be used, I guess, for Helm. Or is it passed to the Cilium library, right? Cilium CLI library.
It's a list of resources of all.
Yes, so here we have the list of resources. These are all the resources that the Cilium provider will be able to manage, and the data sources as well that the Cilium provider will provide. So we have like an install resource. That's to install Cilium. Cilium config. This is to configure Cilium, I guess.
No, Cilium. Sorry. Cilium install is for installation. Cilium config is to add in config map Cilium.
Yes. Is it this one? No, it's
yes.
not this.
Maybe you can share the documentation about Cilium provider.
Yeah, we can have a look at this. Let's see. Terraform Cilium provider. This one in the registry. So here we have here documentation here. So you essentially initialize it by using provider Cilium and the config path. Or you could also specify, like you said, you could also specify the context in this file and potentially the namespace where Cilium is installed. I guess even the config path is optional, right? It would just use the default location.
By default.
Yes. So provider Cilium is enough if you just have one cluster and one config file. And then the Cilium resource will install Cilium. So here we have a cluster that is installed, and then we configure Cilium with Helm parameters. These are Helm parameters, right? Just like in Cilium CLI install. That's correct, right? So this is the version of the Helm chart, essentially, right? The the main way of installing Cilium is actually the main way of installing Cilium is actually to install using Cilium like this with the Helm chart, right? That's the main way for production. And then your provider essentially uses the Cilium CLI library, which uses the Helm provider, the Helm chart.
Yes.
Right? Okay, just a minute. So here we're also activating some parameters. So this is the configuration for the kind cluster, and here we're activating IPAM mode Kubernetes, IPAM operator replicas, and tunnel VXLAN. So one benefit, I like to use Cilium CLI to install Cilium because it detects automatically some parameters. Does the provider do this as well? Does it benefit from the automatic detection that the Cilium CLI does?
Sorry. Oh yeah, about Cilium CLI detection. Yes, it's in Cilium CLI and in Terraform.
The provider, yes.
Provider.
So this is great because one benefit of using the Cilium CLI is really that it detects the type of cluster and it adapts the parameters to this cluster, right? So I guess you get this as well with the Terraform provider. And so what will be interesting is if I don't put anything here, it will detect the right parameters for kind, for example, right?
Yes.
And then it would be interesting to be able to get which values for Helm will actually set. Can I do this using the provider?
It's possible with data sources.
Okay, so there's a data source here.
Yes.
Helm values. Okay, so with this, I will be able to retrieve the Helm values that were automatically added, either detected or the ones that I have overridden myself.
It could be nice. It could be nice to have in a Cilium output.
Yes.
In a Cilium resource, but I didn't integrate yet.
So yeah, and here this creates a local file, but I could actually parse the values and use them somewhere, right? I could use them in another resource. Okay, this sounds great. And then what we're going to use today as well is Cilium for installing Cilium, and then cluster mesh for setting up the cluster mesh. So cluster mesh in Cilium is actually done by activating a second API server in Cilium, which manages the cluster mesh. So this is the equivalent of the Cilium cluster mesh enable command with Cilium CLI. And this will actually be activated with this, right? With the type of service that we want. I'm guessing with kind we'll use a node port because we don't really need a load balancer for two kind clusters. But in production, this would be better. Okay, and here we're going to depend on this. Okay, yeah, because there's no implicit dependency. And then once we have activated cluster mesh on each cluster, we can actually connect the clusters together. Great, and this is to configure something. Yeah, like debug true. Okay, cool. We can try this. So this could be passed actually via the the Helm chart, but the Helm chart doesn't expose. Well, yeah, you can always add something to the config map with the Helm chart, but this is to add something. So what happens here if I pass values here with the resource, and then I override with Cilium config? Will that be idempotent actually, or should I avoid this? Tricky question.
I think Cilium config override the Cilium Helm, the Cilium Install. I think it's more. It's for example, debug equal true. it's very interesting. Temporary. I think it's more temporary it's not for.
Yeah,
I think it's more. It's
a temporary usage, right?
yes,
It's not something you want to keep in your code.
but I don't know.
But
It's just a test to also because there is a Cilium config in a Cilium CLI, so I also do that. But
yeah, I'm just thinking it should work if Cilium config is always executed after the installation. So in case the Helm chart is actually updated, then Cilium config will set the value again, and then that should work. Okay. And then this is to activate Hubble, so we can see what's happening in the cluster. So this is the equivalent of the Cilium Hubble enable command.
Exactly. I think it's also temporary, like Cilium config.
And this is something different, actually. There's no command in Cilium install to do this, right? In the Cilium CLI. So this is to remove
yes,
kubeproxy.
it's disable because I played with AKS. It's Azure Kubernetes, and you can't delete kubeproxy in Azure. It's always when you delete, it's reappear after 2 minutes, or I don't know exactly, but
Okay.
So the solution for that is to select a fictive node to disable this resource.
Oh, I see.
Disable the kubeproxy on Azure, but
okay, yeah. It puts a node selector on the kubeproxy so that it never gets scheduled. Yes. That's tricky. Okay.
It's not. I don't see equivalent in Kubernetes provider or others. So
that's nice.
I think it can be useful for for Cilium. So I create this resource.
Great. Well, maybe we'll disable kubeproxy in our demo, cluster mesh demo, but there's a way to actually do it in kind by setting networking kubeproxy mode to none. So that will be a bit more elegant for kind.
Yes.
So there's a demo you have here. So we looked at it already. We looked at the versions. Now let's look at variables. Which variables do we have?
Variable is input in Terraform language.
Yes.
I don't know why it's not input, but it's like that.
Yeah, that's how it is. Well, yeah. So here we have a hash table essentially, and there's several kind clusters, right? So there's this default. Okay, and so we have two kind clusters here: mesh 1 and mesh 2. Mesh 1 will be called cluster mesh 1 because when we're meshing clusters, we need to name the clusters and we need to number the clusters. And we'll have extra port mappings for this kind providers, for this kind clusters. So what this will do is that the container port that is linked to 32,042 will be linked to the host 32,042, which means that when I access localhost on 32,042, it will link to the container port, essentially to the node port on the control plane, right?
Yeah. I use cluster mesh lab for the configuration of.
Yeah, I can tell. There's other ports I usually choose for my labs, indeed. So I usually expose the Hubble relay on 31.234 and the Hubble UI on 31.235, and I usually keep 32.042 for another application. That's what I do in the Instruct labs, indeed. Okay, and then we have a pod subnet for this kind cluster and a service subnet. And then here for mesh 2, we're not exposing ports, because we're not going to look at Hubble. We'll only look at Hubble on one cluster. And then the pod subnet is slightly different. So in the past, it was necessary for cluster mesh to have different pod subnets. Now it's possible to actually have the same one. And the service subnet here will be different as well.
Okay.
And then we have the Cilium variable, which will configure Cilium for both clusters. So for mesh 1, we'll use cluster ID 1, and for mesh 2, cluster ID 2. So we need to number, at this point in cluster mesh and Cilium, we need to number the clusters. And we will use the Cilium chart version 1.14.4 for both of them. Cool, that sounds good. And then main.tf, there's actually several things. There is kind. So this will install kind on both clusters. It will create both clusters, right? So because there's a for each var.kind. So this will pass the name, pod subnet, service subnet to the module, and the kind module has obviously variables and so on. But it will essentially create the kind config and so on. Did you here also disable qproxy? Because we could do it here. Crap.
No.
I don't think so, right?
No. There is no qproxy disabled.
So here we could actually do qproxy.
Yes.
Qproxy mode equals none, right? Something like this. Yeah, that should work as well. I think.
Yes. Maybe we have to go to kind provider to.
Yeah. Look at the documentation just in case. This is the one, right?
Yes.
Resources kind cluster, and what do we have here? I don't know if it's going to specify this. Does it say? No, it doesn't say. We just put the values. We just put the values here, and the value is, it's qproxy mode with capitals. So, but then no, you need to,
in Terraform it's different. Yes.
Yeah, it needs to be snake case and not camel case. So let's do snake case like this. Yeah, I'm already modifying it. It's for fun. All right, and then what do we have? We have qproxy replacement, right? Cilium will do qproxy replacement here. Or not? I'm not too sure. Let's see. There's a Cilium here, IPAM mode Kubernetes. I think this would be automatic as well with kind, but we don't have qproxy replacement here. So maybe let's leave it out for now, and we can test later with the with the change. All right. So let's get started. Tofu import.
No, init.
Tofu init. See, I haven't used it in a long time.
So
let's do Tofu init, and this will download the providers. If I had done it before, I would do init and then I need to do import as well just to be sure, right? Dash upgrade. No, it's init dash upgrade, right? Exactly. Yeah, no, I'm confused. Okay.
Yes.
Init dash upgrade. So this installs and updates the providers.
You can see the last number of the release. It's 0.1.5.
0.15. Yes, that's the one you released today, right?
Yes.
You released it today. Yeah, this is really, really new. And then we can do tofu plan. So what will this do? This will create multiple resources. It will create a cluster mesh connection. It will create a data.context one. Okay, cluster mesh one, cluster mesh one, cluster mesh 2 Cilium. So that's the installation on cluster mesh 2. This is the cluster mesh API server on cluster mesh 2. This is the kind cluster itself for one, and kind cluster itself for the second cluster. And where is the connection? The cluster mesh connection? It's here. It's at the top, right?
Yes.
Okay.
Terraform data. It's a workaround to wait all installation. It's,
this one, the context one.
Yes, it's
context one. It's this one here, right?
Yes.
It's a Terraform data context one. Okay.
In fact, you wait this. It's just a workaround. It's not very important for for the demo. In fact, if you see in a version TF file, you see this in the last global.
Oh, I see. Yes, yes. It's used to configure the provider for the global instantiation. Hey,
yes.
Hi, Marino. Marino has joined us. Hello.
Hello.
Nice to see you here. All right. So we did the plan. Now let's do the apply and see what happens. So what's expected is that this should create 2 kind clusters, install Cilium on the kind clusters, and configure cluster mesh. Oh, one thing I'd like to do, maybe, can I do this? I'd like to have, just to keep things clean, I'd like to create a cluster 1.yaml and cluster 2.yaml and store the kubeconfig configuration in these files. Is this possible? Can I do this?
In the module kind.
In the kind cluster, this should work, right?
Yeah, I think it's already the case.
Oh, is it already the case?
Yes, it's not the same name, but
that's the name. But does it store it in a different kubeconfig file, just to keep things clean? Kind cluster. There's a kubeconfig for the cluster after it is created. So I think this is what I need to use. This is the attribute kind config kubeconfig path. So what I'd like is kubeconfig path, right? And that's the top argument here. So kubeconfig path equals, and I want something like var.name .yaml. Can I do this? Let's try. Let's see. It should create. Where is my kind cluster here? Kind mesh here. Name kubeconfig path is cluster mesh 1.yaml, right? So I'll just remove this to cluster 1 and cluster 2, and normally it should create it actually. So let's try this. Apply. I'll open a new window here to see if it actually creates it, right? So far, no, but it takes a little bit of time to create the cluster. So I'm hoping this will work. But I really like to have separate config files for the different clusters so that it doesn't clutter my general kubeconfig. Right.
You see the TF state. TF date.
Let's see, kind list cluster. No, it's kind get clusters.
Yes.
So the clusters are there. Yeah. Just okay. Oh, and it did create cluster mesh 1 and cluster mesh 2. Great. This is great. That's what I wanted.
Now Cilium.
Now it creates Cilium, right? So I can do something like this. Cilium status, and Cilium status won't see much. I will need to add what I will do is that I'll just use kubeconfig equals cluster mesh one.yaml. And here I can see what's happening. Right, it's being installed. Or I could do kube control -n kube system get pod. So yes, Simon, all episodes are recorded, so you will find this later. Don't worry. In fact, you can watch from the beginning if you want. It's just that you will miss the live, but you can actually go back on YouTube. So here we're seeing the installation happening. Right, kubeproxy is here because we didn't disable it this time. We'll see if we have time today to disable it. Where's the configuration? Ooh, there is an error. What happened? Plugin did not respond. I guess it might be it might be a timeout or something. Let's see the status. Cilium status here. So everything is established properly. Cluster mesh is activated on cluster 1. And cluster mesh is also activated on cluster 2. And we can see cluster mesh status. Okay, this is a service type node port. Is this what was configured actually? I guess.
Yes.
Cilium cluster mesh using, but it uses node port by default maybe. So it's no.
I think you can change.
Okay. Oh yeah, it's here. And the main.tf is node port. So node port is not what's recommended to mesh Cilium clusters, but because it's all on the same machine, there's really no point in setting up a load balancer actually. So this is here cluster information, and here the cluster, no cluster connected. So it's just that the mesh did not happen. All right, well, let's try again. This is idempotent, so we can do it again. It's all right. Probably a matter of a timeout, I guess. I think in the no, this is not it. Right? Invalid memory address. Do you want to debug this live? We can. I don't mind. Cluster mesh.go. Oh, this is in Cilium CLI cluster mesh.go. Okay, connect with Helm.
Maybe you can test 0.1.4 plugin, maybe?
Sure. Yeah, let's do that for now. So it's here. I will specify 0.1.4, and I want exactly 0.1.4.
Yes.
And tofu we need upgrade. And let's apply again. Crossing fingers. Nope. Same problem.
That's very strange.
Do you want to start from scratch? We start from scratch with 0.1.4, maybe. Then we can debug this another time. Let's remove all the clusters. I won't do a destroy. I'll just remove the status manually. This is ugly. You're allowed to insult me if you want. I just know I'm not leaving anything behind because the only thing that was created was this and the cluster mesh.yaml files.
Yes.
So let's do apply. This is all right. This is live, and we're meeting live issues that happened. So can get clusters. We have the 2 clusters coming up. But because they're not up just yet, we don't have the configuration files yet. So we need to wait a little bit. Let's see, can we see maybe from the config, what exploded here? What was this? It was here, you using Cilium CLI version 0.15.20. Is there a V? Yeah. and cluster mesh.go, and the line is 2078. So this is where it explodes. Let's see if this is finished already. Still creating. Oh, it's creating the. Sorry, just gonna keep an eye while it keeps going. Yeah. Okay. So Cilium status. So Cilium is installing. Now I will activate cluster mesh. Okay. So what could be the problem here? Why would this explode? That's a good one. All right. So it's activating cluster mesh now on both. Do cluster mesh status here. So cluster mesh is activated here. And yeah, we have the same problem. Oh my. Oh, sorry about that.
That's strange. I tested this morning and it works.
It's all right. Is it because of the change I made? Because of the files that I'm using?
Maybe. You did.
It sounds weird, right? But it could happen after all. I did change this, so let's do this.
It's also kube proxy.
I did not change this. I kept it.
Okay.
Yeah.
Try a Terraform destroy.
Oh well. Yeah. It's the same.
Yes.
And the state, and there we go. Let's do apply. Okay. I still would like to figure out while this is applying. Oh, come on. While this is applying, I still would like to figure out what could be. If it could be linked to the files, what would be the reason? That maybe the global. I'm thinking maybe the global provider is unable to access the context because they're not in the same file. Could that be?
Mm-hmm.
Because we have this global provider.
Yes, it's maybe. Do you have the global? Don't use the config path, so it's the cube slash dot cube slash config. It's the default. Maybe there is problem.
Yes. And this here, yeah, there's no config path here.
Yeah.
So we would need something like this actually. Yeah, I'm pretty sure that would fix it. We would need to do something like this and include both of them.
Yes.
That would probably fix it.
Maybe.
Okay, but it shouldn't explode like this. So maybe it would be. I'm sorry, I broke your. I broke your code. This is fun. We're here for that.
It's a experimental provider.
Yeah, no, and I mean, I'm not at all blaming you. I mean, I'm doing crazy stuff that is not in the documentation. So, all right, but it did create two config files by default.
Yes.
I mean, it didn't put it into my kube config. I don't think it did. Oh yeah, it did. So it does both. Interesting. And now it's doing the connection. Okay, so let's do the status here. And it's called what? Cluster mesh 1 config. All right, let's do the status. That is looking good. Yeah, it all applied. So it was my fault. It's confirmed it was my fault. Okay, I'll stop changing things around. Great. So now we have connectivity, we have this configured. Did we activate Hubble? Actually, I don't think so. Huh? No. Yes. I think Hubble was activated on 1. No.
No.
Not yet. No, it would be in variables. No, in variables we have exposed the port here. Yeah. But we haven't activated Hubble yet.
No.
So let's do this on the second one, on the first one, right? So we can do the resource Cilium. Is it called Cilium Hubble? Is this what it's called?
I think so.
Cilium Hubble.
Yes.
We need to give it a name. Cluster mesh 1. And how does this work? We need the namespace, and we need we'll need to specify the provider, right?
Yes.
We specify this, and then UI equals true if we want the Hubble UI. Yes.
In the Terraform, it's not providers; it's provider.
Oh yeah, sorry. Yeah.
No, it's yes, and it's there is only one provider, so
yes, it's
you have to change a provider equal cilium.mesh1.
Okay. Yeah, just checking this here to be sure what I'm doing. Yeah. So it's provider equals Cilium mesh 1. Yeah, you're right. Yeah. I had providers. Come on. I had this here because this is passed to a Terraform module, and the Terraform module then passes it to the resources. But this is the syntax for the resources.
Yes.
Okay. Great. Thoughtful plan. It's not a bug. It's a feature request. Yeah, I will open an issue anyway. So what's missing here is activating Hubble. Great. Lie. So this will be the equivalent of using Cilium CLI and typing Cilium Hubble enable, right? Because like you explained before, this actually uses the library from Cilium CLI. So you use the abstraction that was built in Cilium CLI for this. Okay, so then if we use our kubeconfig cluster mesh 1, and we have a look at -n kube system, get pod, what do we have here? We have the cluster mesh that is enabled. We have the API server running. Cilium is fine, and Hubble UI are exposed. The thing is, by default, the service for Hubble UI is actually a cluster IP, and we'd like to expose it. I don't want to put an ingress in front. So I do this manually just so that we can see what's happening. Ideally, we should patch it with the Helm chart, but I'll do this manually, and we don't tell anyone, right? Just to check if it's working. So I'll just edit the service for now. Hubble relay. So Hubble relay, and it will be a type node port, and the node port here will be 31234. And then we do the same with the UI. It will be a type node port, and here node port 3123. Oh, I put 5 already for the other? My bad. It's 431. Yeah, no, that's what I did. 31234. Okay. And so services, we have 31234 and 31235. Great. Now can we use Hubble and see what's happening? So Hubble server equals localhost 31234 Hubble list node. This is not working. Connection refused. What is missing here? I think it's probably the kind configuration. I'm not sure it actually forwards here. We probably made a mistake in this one. And this also couldn't connect. So So yeah, it's probably the kind configuration that doesn't forward it properly. Let's try forwarding it just to see with the proper thing here. Yeah. So Cilium Hubble port forward. And now here, if we do Hubble, its nodes, we can see the nodes. This is great. This is interesting. And can we see Hubble observe? So we can see the traffic here. And now we can actually expose the UI here. See, it should forward and it should open in my browser here. Yeah. So this is the Hubble server on, I'll zoom a bit, on cluster 1. And if we look at Cube System here, we can actually see things happening. But we still have about 10 minutes. So I suggest we deploy something to test the mesh, right? Let's do that. Now it goes really fast. Isovalent here. Tracks. Let me find the usual demo thing. Something like that. We'll have a deployment and a service. Right, so let's do this. I have a deployment here, which will deploy the usual Rebel base and X-Wing, and then a service here. Okay. So kubeconfig here and kubecontrol apply-app deployment and service. This looks good. And I'll do the same with cluster mesh 2. Can you close, please? All right, so we have both here. If we go here, we should see it in default. Oh no, because we're not making requests yet. So we have a Rebel base. We're going to make a request here in cluster mesh 1. Kubecontrol get pod. So, oh, it's still creating. What is it creating? Describe the pod. Failed mount. Why? Oh, there's a config map missing. I need to create a config map. So I have a config map here. Yeah. This is config map for the first cluster and for the second cluster. This is taken from our labs because it's just faster this way. So kubecontrol apply-f config map coordinate on this one and config map tion on the second one. It just has a different configuration so we can see which cluster we're getting to. And now this should get fine eventually. So get pod. Come on now. Rollout restart. Deployment rebuild base just to help it recreate quicker. Describe pod. Yeah, it's running now. Okay. So now exec-ti, we'll get to an X-Wing here. And we'll do a curl to rebel base dot default. And you see we get to the coordinate cluster. This is the first cluster, right? If we do the same thing in cluster mesh 2, and we'll just exec to, well, let's use anything, deploy/X-Wing, that will do. We'll get to tion, that's the second cluster. So this is working fine. Now we just need to mesh them to make global services. So we'll just edit the services and we'll add an annotation. So what is this again? service.cilium.io/global true, if I remember properly. So now kubectl apply -f service, and the same for cluster mesh 2. And now let's make a few requests. And now you see I make different requests and it's actually going to different locations. I'll do the same on cluster 1. So obviously, ideally, I should use some kind of declarative thing to deploy this thing. If we had the time, we could have used actually the Terraform for this. We could have used the Kubernetes provider or even the Helm provider and created a Helm chart for this. So here we can see that the X-Wing on cluster mesh 1 is reaching out to the Rebel base on both cluster mesh 1 and cluster mesh 2. So this is successfully meshed. Great. maybe we'll have to plan another episode to actually disable kubeproxy, configure the kubeproxy free with access to kubeproxy by its port, and also make sure that the the port, the node ports for Hubble actually work, because I don't know what happened with this. This was quite surprising. All right. Pretty cool. So I'll have to open the issue for the for the problem we encountered, but this is very promising, and I think it will be really cool to see where this is going next. Cilium CLI has other features that could be really interesting, I think, with the Terraform provider, especially when it comes to BGP peering, for example. I'm thinking about this because we have CRDs to configure BGP peering. So we could use the CRDs for this, but maybe the Cilium CLI the Cilium CLI library could be used to maybe wait for peering to happen and then something else is deployed. I don't know. Just thinking of different things that could be done with this that could be interesting. I'm definitely excited because I think so far a lot of people have been deploying Cilium with Terraform using essentially scripts. Essentially, when it came to cluster mesh, was essentially shell scripts being executed and launching cluster mesh. So this is very nice.
Thank you.
What are you looking forward to when it comes to this provider? I saw you also ported to Pulumi. Is there something you're still looking to implement in this?
For the moment, it's the provider is a little bit in pause because I don't have a lot of time for that. But when I have time and you have some ideas, I can implement.
Right. Well, and I'm sure maybe there'll be people that want to contribute to it as well. That would be cool.
I hope so.
Yeah, that would be really cool. All right. Well, we're pretty much at the top of this hour. I don't know if there's any questions. I didn't look too much. There's some people that joined us since Nikos joined us. So hi, Nikos. That was already 10 minutes ago. So yeah, and yeah, I hope you all enjoyed this episode and that this was useful. So don't hesitate to go and contribute to the Terraform provider. I'm sure Joseph will be happy to see contributions, and I'm sure there's still a lot of things that could be done to improve this and make it even more featureful and useful. That's definitely, I think, it's a great direction to take to integrate Cilium into more like DevOps and DevOps oriented and idempotent processes. So very cool. Well, thanks everyone. I'm going to hide this. Yes. Thanks everyone for participating, and I hope to see you another time.
See you.
Bye, Joseph. Thank you for coming.
Thank you to you.
Bye.